Good afternoon. This is Pops. I figured I'd pop on here because once in a while I like to do a little tech deal on YouTube and political, religious, whatever. You know, I'd say politics and religion are two things you should never talk about. What's left? The weather? And you already know you paid too much for your food and gas and your car's going to break down. Come on. Cowards. Anyway, I said something the other day on Facebook, I think it was, that I'd come on here and do a little video discussion about troubleshooting deal we just had. Now, one of them was I got a phone call that a fellow bought a bulldozer and there was a problem with the drive system. We went out and did some troubleshooting to make sure that the controls of that drive were right. He had 3 speeds on one side and 1 speed low on the other. Well, low is the default when everything else goes wrong. We got in there and looked around and couldn't find anything. He didn't have a parts washer of any kind, and spraying brake clean in those holes just kind of turns me off, and apparently wasn't any air available. So, at least not enough with a reasonable control that I was going to blow things out. But I turned things over, looked them around, the valve wouldn't come out one way, so I said, well, we'll pull it out the other way. And apparently something fell out the port that we didn't see. It was so tiny. Put it all back together, and when the valve started moving, I was like, well, we got something here now. He says, well, let's try it. Put it together, and it worked. But before that, what we did was I actually got a manual, found out where the 3 speeds were. In an excavator, they're different than in a bulldozer. In the dozer, the motors are more complicated. All 3 speeds are in the motors. And you just change your drive output, speed, flow in this case, from your pumps. So the pumps are controlled here and here for steering, left and right, but the speeds are completely controlled in the back. As I said, default setting is maximum stroke for the motor. So what's that do? That gives you your most power, the longest stroke, but it takes a lot more oil to turn it. Excuse me, because of that long stroke. So what's speed 2 is mid-stroke, and then speed 3 is minimum. Just a little short, each piston going in there. Low torque, but more speed. Well, we got that fixed. A little while later, I get a phone call. It seems like it's overheating. What do I do? I said, well, we did a check. And the check was actually pretty simple. So what do you do? And I said, well, you turn the key on, unplug it. What happens? He says, it goes to 0. Okay. He says, I got nothing. Right. You should. You're saying it was overheating before. Which is bad? Is the gauge overreading or the sensor overreading? So in this case, it's not a switch, so we call it a sensor. But anyway, then I said, get a test light. And he said, why? I said, well, get a test light. Because the problem he had was that what he was describing was a sensor. So he replaced the sensor and it still didn't work. In the meantime, we were trying to troubleshoot the gauge and the wiring coming down. They said, well, take a normal test light, incandescent bulb, old-fashioned one. So across the terminal, and so what I did, I got a little bit of light. No, I don't care about your little bit of light. As long as you know the light works, what's the gauge doing? He says, oh, it's about halfway. I said, okay. Then you know your wiring and your gauge generally work because that's usually where it ends up. In a standard old-fashioned analog, which most of your temperature gauges for your machines are, your standard old-fashioned inverse operating analog temperature systems. Even on newer trucks, trailers, and whatever else has a sensor in it, your hydrostats or whatever, if it's 2-wire, it's going to be your basic system, your analog. Why? Well, and it's inverse. What do I mean inverse? As the temperature of your engine or hydrostat oil goes up, the resistance goes down. Why do they do that? I don't know. No idea. It's backwards intuitive. That's why they call it inverse. If you take a wire and you get it hot, then the wire loses its conductivity. The resistance goes up and it makes more heat. Yeah, that's typical. So that's what we normally would think. But for these, it's inverse. So his temperature went up. Resistance should have come down. What happened was the old sensor, the temperature would go up and resistance went down so far the gauge was doing one of these. Or going up. Yeah, going up. Too fast and too high. So he puts the new one in, he got nothing. Now what? Gives me a call. Let's go check. Okay, now at this point I want you to get out your pen and your writing pad. Okay? Let me see if I can follow along with you to make it a little more palatable. Now I have a gauge. Okay? I'm going to make it that way. Round. Isn't that pretty? This one has 3 terminals. I'm going to draw it up that way. Plus, minus, and signal. Okay. Minus, that's your ground. GND or GRND or just plain G, that's going to go to ground. Okay, you can draw your ground just about any way you want. There's 2 different styles, but I'm going to use the general battery ground style. And the other one is your battery plus. You're hot, but it's key hot. So in foreign terminal style, your ground would be number 31. Because I think 31 and another number, but 31 in general is your basic continuous ground, like your frames, your ground wire, everything is connected together. It's a basic ground, is number 31. Your key hot, though, key on, KO, as a lot of people would call it, actually would be in the European sense and a lot of SAE, whatever. Your legends and your labels would be a number 15 wire. Okay? Now, this is easy. You know plus and minus are there. Now here's the curious part. Signal goes to the sensor and goes back internally to the ground. So one side is plus and the other side is still signal wire going there. In this case it's yellow, so it's going to be a Y. Follow me? Okay, hold it there for a second for some of you that might actually be following. Okay, there's your signal. There's your ground wire. It's just that simple, and it grounds up through the gauge. It really does, and goes to ground. I grounded it under the dash. I grounded to the wires that go into the entire panel, monitor panel, and grounded to the engine to be sure that was there. So it was an entire grounding system, and it was all the same. Anywhere between 1.1 and 0.9 ohms. Plenty good. Well, that's not perfect. Well, the meter can account for that much. And the wires and the connectors, so just leave it alone. It's generally considered a good circuit, 10 ohms or less. Okay? That's how that is industry-wise. So you got your ground up top. Over here's your plus and your signal line coming to the sensor. Curious part was the new sensor showed nothing. Well, so I told him, we pulled the plug, put a test light. Test light went up. It was a different kind of test light, so it went up to about 1/3. But it did come up. So the gauge in the basic system is working. No, that's not perfection. Because the only volt we had down there was like disconnected was 6.8 volts. Connected with 6.8 volts. It didn't care. It isn't reading because the resistance, as I found out, was astronomical. The new sensor came through, and we looked in the manual. Anytime you can get your hands on a manual, do it. In this case, it made things much easier. We went by a temperature chart that they had there, and originally I misread it. I thought 50 degrees. I took it. Hey, look, 50 degrees. No. That was 50 degrees centigrade in the chart. Or Celsius, whichever you want it. Centigrade's old school, Celsius, same thing. Identical. Don't argue. Shut up. So you have 50 degrees Celsius, right? I pointed 50 degrees. No, wrong 50 degrees. That was Fahrenheit. Flip the switch, as we later did. It was 20 degrees Fahrenheit, or Celsius. 50 degrees Fahrenheit, 20 degrees Celsius. The chart was in Celsius. C. Oops. I made a boo-boo there. We went up, checked the gauge, we checked the wires, double-checked the ground, and that's what I was working on. And we knew the gauge worked already. Checked the connectors, they were all good. The grounds are good. The line going down was good. Plug in the sensor. It's like, something's wrong here. I couldn't read the little K. 57 K ohms. 57,000 ohms. I read that down there, only I didn't read all of it. Found out it was K ohms. I triple checked it. Sensor is at the temperature was 57 K ohms. Well, it's supposed to be that at 50 degrees centigrade, not 20 degrees centigrade. I already had a problem. The sensor's way out of whack if the engineering information is correct. So we plugged it in, checked it, and everything up to the gauge was fine. Test light, up to third. The original, the original test light was a different one. Probably a full incandescent bulb. Mine was kind of a funky colored thing. It may have been a 24 volt, I can't remember now. But I plugged it in. It came up very dim. Then I looked at it and said, oh, okay, cool. Up to about a third. That means your wire harness and everything else is working. Trust it. It may not be perfect, but in general, your wiring is working. We didn't need to take it all apart, but taking it all apart, we were able to start from the top, go all the way down, and confirm there's only two connectors, one down here and one up here in the back. So that took the hot wire, tested it to ground because we unplugged the gauge. Now we can isolate the wires for ground and for the signal. We can double check the voltage going into it, and I did. Battery volts, 25. So we were doing pretty good. Put it all back together and nothing's working. Of course it isn't. Because now we have the wires confirmed are good. They're not grounded. They're not shorted. We have power to the gauge is good. So I have 25 volts where I'm supposed to have 25 volts. Key off, 24 volt system. It's a little high, but close enough. You just got through running it a little while ago. So then our ground is excellent. 1 ohm, say 1.5 ohms or less. That's very good. And see, you got voltage, you have ground, and now your signal wire has almost 0 ohms on it as well going down to it. And because I had a spare, I was able to check to be sure that the contacts were good. They were. Contacts and the sensor were good. So what does it add up to? What it added up to when he put it in and it didn't work, sometimes the sensor body has to be grounded. Well, he grounded it, nothing happened. That's correct. Nothing would have happened. The body wasn't grounded in this one. But it showed in the book that it was. You need to confirm those things. But still, we grounded the body just to see if that would make a change. Because the book had that in there in one engineering drawing. I believe in the troubleshooting. That can screw you up serious. But it didn't make any difference in this case. Didn't matter. What we knew by A, we had full voltage to the meter. B, we confirmed the grounds, top and bottom. We confirmed that none of them was shorted on either wire. And we confirmed that the plug was snug and tight and clean. I cleaned it as well while I was there just to be sure. And the sensor and its plug were new and good. And we also confirmed we didn't have a ground to the block, and we're not going to have a ground to the block. Sensor was not designed for it. Because you hook to the ground on your wire and hook to the ground of the body, or there's no contact there. So if there isn't, it doesn't matter whether you ground to the body or not. Because he had that with a lot of Teflon tape in there, and sometimes that's not so good. Anytime you put a sensor like a temperature sensor in there, you're better off putting in some type of paste. That's correct. Much better, because what it does is fills the void between the metals. It doesn't stay on the outside of the metals. You'd say, well, the thread should cut it. You think it would cut Teflon tape, but sometimes what happens is if you get enough tape on there, it starts to bind between the tape and the threads. That's right, longitudinally. And that'll cause a problem. So the threads will never actually touch the housing. The Teflon tape will be there. And sometimes there'll be enough at the tip of the threads, even though there's enough threads that the pressure here, as it starts to close up, will bind up. I've seen both. So sometimes you have to be careful. I recommend some type of heavy duty, smelly PTFE or similar pipe dope that's designed for the temperature and the pressure you're working with. Well, in this case, it didn't matter. And when he got everything all down to it, he paid me $150, which is dirt cheap for the time we had, so that he could go and tell them their $200 sensor was probably the wrong one or a bad one. They got there and found out that even with the serial number, he took the old, he took the new, and showed it to them and said, "Oh, you got the wrong one. We'll get you the right one." But we went through the troubleshooting aspect like that. Your power, your ground, and your signal. Check their integrity. And the funny part is, while I was online, or on the phone with him, I should say, we pulled the plug with the old one. You pull the plug because it was reading too high. He pulled the plug and it went down. And you put a test light on it, it goes halfway up. All of that troubleshooting is immediately done. But because we had a question mark that the new part didn't work, we went back through the full troubleshooting, from the power to the ground to the signal to the wire, all of it. And when we confirmed that it was all solid and good, nothing shorted, and no high resistance in there, because in this case, you could have a 20-strand wire and 18 of the strands bad. But the sensor doesn't care. It's only moving a few volts anyway, or a few microamps. It doesn't care. So we could still check the integrity and still have it working that way. But what told us as much as anything else is, put a test light in there. It barely lit up with that, let's say 7 volts on a 12-volt light, which it can do. And it brought the gauge up halfway. His day is over as far as from that plug up to the gauge. Why did he call you to confirm it? Because he was having trouble and got the wrong sensor. And rather than call the dealer at $150 an hour, who's going to charge him for it anyway, hires an outside guy that used to work at the dealer and went back with the information, and they took the sensor back and we're going to give him a refund and ordered the proper sensor. That's all I can tell you. They got it back in pristine condition in the original box, everything in good shape. You're all set. $200. You're darn right he took it back. You say, yeah, but he paid you. Hey, he paid me. And here's the funny part is, because he paid me and we went through the troubleshooting, he could describe it to them what the problem was, and they were guilty of the fault because of that, and they covered it for him. You say, yeah, but no, he saved $50. Let's put it that way. He was able to get his $200 back for the sensor because I gave him the information that he could take it back to the dealer, even though it's an electrical part. It works. We could have done a lot more when I was talking to him on the phone if he'd accepted the fact that you pulled the plug. When it was overheating, you pulled the plug. That's good. You check your volt, put your test light on, it goes part way up, you're done. But he didn't want to accept that, which is fine. You go right through it to make sure that when you do take it back, I spent all this money to have the troubleshooting done, and guess what? This ain't the right one. Oh crap, they found out, even with a serial number. No, it's not the right one. Something to keep in mind. And the other part is to keep in mind is I almost made that blunder until he said something. Now that's Celsius, right? And I was like, I don't know. It said 50 degrees. I saw 50 degrees and figured we're there. No. 50 degrees in Celsius, roughly, we calculated is somewhere between 110 and 120 degrees Fahrenheit. Nowhere near there overnight. And that was a blunder that he mentioned, and I went back through to check it, and I was going to check it again anyway. But he mentioned it when we made sure to double check. Aha! Your dozer's fine. We found corrosion. We found bad parts. Figured that the panel may or may not be 100%. But what we're getting out of the panel in the basic operation, it could work enough that they could use it. But the sensor we were calculating was definitely the wrong one, which made him happy because that monitor panel was $1,200 plus. shipping and handling. That's why he paid the $150. Yeah, sure, he's got $350 involved. But now he knows what he has. Troubleshooting, it's an art form because you'll go through and you'll make those mistakes. What's the idea? Go back through and check it again. Double check your mistakes and write down your denominations, so to speak. Write down your Fahrenheit, write down your Celsius, write down your PSI, your volts, your milliamps, your ohms, and write it down as such and list it. And that was part of what I did. Started writing some of the stuff down so it wasn't just in memory. You reach my age at 63, you have so many things in your head memorized that it's easy enough that on a good day even that you can transpose stuff that it can cause a problem. Anyway, you folks have a good day. And then remember, troubleshooting is an art form, something you need to take your time at. And when it comes to electricity, in general in systems like this, it makes it much easier. What was another thing that made it easier? It had little pins, little breakout pins, teeny little guys. I could clip the meter to it and put it inside the contacts without affecting the contacts, which makes it even better yet. Small little things like a good meter, good leads, changeable end leads, all of that makes the whole job a heck of a lot nicer. Get your equipment and a good equipment. Catch you later.